All right, hey, let's talk about reducing the attack surface and a unique approach that we have created here at Full Armor on how to reduce that attack surface in a very significant way. Now, let me just talk about why that's important. What's happening in the industry now is over the last several years, people have started to realize that firewalls and VPNs and all the blockages that you would put to thwart attack attempts has not been always successful. And actually, if you look at all the different attack vectors that have come and the more kind of public profile attacks, most of those breaches are happening from the inside. When you look at supply chain breaches and you look at even social engineering attacks, they're all about getting into the network and then mining and grabbing the data from within. And so once a threat actor is already inside your firewall, all the firewalls are gone and they're inside your network watching and looking and searching for data elements that they can search for and critical data that they can either encrypt for a ransomware or even steal off before you even know it. So reducing that attack surface from even within is a very critical thing. And so one of the things that we came up with and we fell upon this idea almost accidentally. And sometimes the best product ideas or the best inventions happen by accident, right? I think I love the story about how rubber was invented. It was completely by accident. Some guy threw some material onto a hotbed, and it actually formed into rubber. And so a lot of things happen by accident, but it's understanding how that accident can be used for a beneficial creation or beneficial gain. So in our company, one of my chief architects actually brought up two virtual machines in Windows Azure to do some workloads. And then he went to lunch, and then less than an hour later he came back, and those two virtual machines that were completely empty had over 5,000 attacks on it. And initially he was like very upset and annoyed, but then he kind of put his hacker hat on. He was an ex-CIA hacker, and when he put his hacker hat on, he thought, wait, how did these, it's probably not individuals, he knew it was mostly bots and malware, automated malware. How did they find my virtual machines? When he's put his hacker hat on, he kind of started to realize, wait, what I would have done as a hacker or a hacker that's creating bots is I would do open port searches. And so what he realized is all the computer systems out there have open ports. And I think in general industry, your general assumption is you have to have an open port in order for a server to operate, right? You have to have an open port like port 80 to have a website accessible from a browser. You have to have port 22 open for SSH. You have to have different ports for RDP, and even if you change the port number, you still have an open port somewhere. And so what hackers are doing is they're just doing open port searches. They'll find out the IP address of the computers, do open port searches, and then they'll start pinging the ports and trying different methods to break in. And the top by a lot of different attack statistics, over 80% of attacks that come in initially are through SSH and RDP and even SFTP. So a lot of these basic connection-based utilities that administrators use to administer local machines are the entryways in. And then, of course, you have open ports for SQL databases and file servers and whatnot. Now, my administrator, as a hacker, sometimes his first assumption is to, how do I get around what everybody assumes and go around and do something that's different, that no one has assumed, right? And so what we did as a company, we decided, hey, can we operate or remove the need for all open ports? Maybe that premise is wrong. Maybe the premise that every computer has to have an open port is not correct. And so we spent a year and a half creating a solution that allows you to operate all your native apps exactly the same way. No changes, no configuration changes. And our mechanism, our tool, which we call SSHepherd, will remove the need for all open ports. And we automatically, and without going into too much detail, what we do is when you initiate the client to connect to an application, we initiate a connection to the local port of the machine instead of the open port of the application. When we initiate the connection to the backend service, whether it's a website or database or whatnot, we initiate a reverse tunnel through the local port of the machine. And now what our Shepherd server does is connects the local ports tunnels together in a secure tunnel. And as a result, you can now communicate point to point from the end user to the application, point to point communication. And that is actually the way the network should have been designed. I heard one of my good friends, he's an ex Red Hat hacker, describing this whole evolution of computer networks. And one of the things he was talking about is the fact that we designed the way computer networks operate based on kind of how we understood how telephones operate, right? So if you have a telephone and you have a phone number, anybody can call you, right? And you don't know who's calling when the phone rings, so you answer the phone and then, hey, wrong caller, and then people can spoof you and they can start, I don't know if you've ever had prank phone calls happen, not a fun thing. The problem is we arranged and designed our whole network infrastructure, computer network infrastructure, in exactly the same way, because we thought, hey, this is how the telephone works, this is how the network should work. The problem with that is that's not how you want to actually connect. You want to have a phone system or a network system that only connects with people that you want to connect with, right? And it should have been a point-to-point connection system, not a point-to-all. And so as a result, what we're doing now is creating these security mechanisms to try to mitigate unwanted calls, right? You got DDoS attacks and you got open port searches and whatnot. If we designed our network correctly, and the ideal operation of our networks is to have point-to-point communication. The end user, the end client, communicating with the end application, and that application only. And that is what Shepherd does. It closes all the open ports, or we don't close it specifically. We give you the option so that you don't have to have any open ports. And a lot of our customers, especially in the government space, took more of the draconian approach, and they literally close all the open ports, and their threat vectors have gone down to almost zero. Because now you create a point-to-point communication system where only authorized users are connecting with authorized applications, and they have no access to anything else. So it's like having a private line to only the people that you want to talk to. Now there's no prank calls, there's no unwanted searches. No one's gonna know your phone number because it's not public, and no one's gonna be contacting you and trying to spoof you or hack into you. And that's really the whole value of the Shepherd product. What's great about it is it can be installed and implemented across any existing network infrastructure. So this is an additive solution. So even if the hacker is inside your network, you can actually, when you implement Shepherd, they would see an empty house. Essentially, they would be inside your corporate network. Let's say they got the way in through social engineering or supply chain attacks, and they're inside your network. When they do a search, nothing will come up. It'll look like they're in an empty house, and they then move on to the next target as a result. And we've seen this happen as a result in many of our implementations in the corporate realm. So I'll leave with one last example, and my buddy who's a Red Hat hacker, he actually put together a demo that you can only run really once, so we had to record it. What he did was he downloaded a NotPetya virus, which is a virus that was created by Russian hackers back in 2017. And what it did was it caused more than $10 billion worth of damage. Essentially, the virus would infect the computer. Once it's infected, it actually searches out other computers it can infect. Once it infects the other computers, it then goes ahead and formats the current and deletes the data of the current machine. So it literally just went through and created a wave of destruction all throughout corporate networks. Now, what's very interesting about this is that this was kind of the predecessor of all botware, and how botwares and the mechanisms it uses to infect itself or use itself to infect other computers. And so one of the things that he did is he put two identical environments together. One environment had all the firewalls of VPNs and routers and gateways in place with Linux and Windows machines, and an exact identical system, but with Shepherd installed. And long story short, he deployed, and he has a copy of the virus, so it was kind of interesting. So we recorded this. He deployed the virus onto the pristine environment. Within 5 minutes, the machine that the virus downloaded on obviously got infected. It then went and discovered all the other machines in the network, replicated itself and infected the other machines, and within 5 minutes, every machine was down and it blue screened. Then he actually went over to the identical system, but with SSHepherd installed, did the exact same exercise. The NotPetya virus downloaded, infected obviously the machine that he manually downloaded on. He actually was tracking the way the virus is operating. It then tried to look for other machines to infect. Because all the other machines had no open ports, the virus couldn't find anything to latch onto. And as a result, finally it gives up and formats the machine that it was infected, but all the other machines stay up and running. So this is a very powerful demonstration of why you need to remove and reduce the attack surface, but also how SSHepherd, in this unique approach of removing the need for open ports, really creates a better additive and even an expansive security posture for your organization, for your corporation.